Today in this video, I'm going to be running you through DMVPN. Possibly, if time permits, I'm going to be uh, adding tunnel protection to it. So basically, this is the lab that I have. I have set up basic static routes between all these three sites. We have spoke 1, spoke 2, spoke 3, and spoke 1, spoke 2, spoke and to spoke 3. Basically, I'm going to be configuring DMVPN on these three routers, and I have static routes to establish connection between each of the routers, except for the switch behind the routers where I have just switch. I'm going to configure static route, but I'm sure it's not going to be in this video. I might even have to split this video into two, but let's jump straight into the configuration to see how it looks like configuring the MVPN. And I'm going to be explaining, as we all know, that the basic advantage of DMVPN, one of the advantages that it supports both unicast and multicast routing, as compared to the traditional using the policy-based routing, where you have to specify source to destination. Policy-based routing only supports uh, a unicast routing. But in DMVPN, uh, I'm not going to call it one touch because it's a one touch, not zero touch. One touch, you can have the hub router configured, and the remaining spoke can be deployed, and you have them connected to the once you have them connected to the internet, they easily join the hub without any additional configuration. Pardon me with all this mismatch. It's EVNG community that's displaying all these error messages. But we can manage with it without. I'm going to be explaining what I am doing, why I'm doing it, each of the features, and why you need to use them. And pardon me if for some reason there is any one of them that I omit. And I'm just going to jump straight into the configuration. So basically, what I'm going to be following is I'm going to configure the hub router first. Then I'll move to spoke 1, then I'll move to spoke 2, then I'll move to spoke 3. After initiating configuration between these three sites, I'm going to configuring the entire uh, DMVPN configuration on these three sites. I will be running a named mode EIGRP between these sites. Uh, we all know that a named mode EIGRP can work conveniently with classic mode EIGRP, but named mode EIGRP gives you the advantage uh, to do some features, to perform some features which you might not be able to do in a classic mode EIGRP. But we are not in an EIGRP class, so let us jump straight into the configuration. I'm going to be configuring the hub first. Then after the hub, I'm going to move to the spoke. Then from there we can complete the rest. So the first thing is I'm going to be showing you the IP address to uh, printing your mind exactly what I have. I have this facing the internet, and I have this facing the switch. So uh, the first thing you want to do is to ensure you have uh, reachability to all your spokes, which I am sure I do. Oh, sorry, I'm doing that on the global configuration. Yeah, it's right. It's right. 35.0.0.2. Is there any problem? Okay, I think I have reachability issue. Let me just jump in to check what could be wrong. Um, um, spoke 2 is 35.0.0.2. So why is my hub unable to reach it? Okay, so I have my hub here. Okay, let's quickly verify why it is reachable. Um, While I'm doing that, I'm just going to verify other ones. Ping 25.0.0.2. Oh, for some reason I can't reach it. Okay, now I know. Um, a static route is meeting on this router facing the internet. That is where the problem is. So I'm just going to run a static route as we used to do on my internet. So it should be reachable now. Yes, so we have that ready. 25.0.0.2. We have that. We have 45.0.0.4. I'm sure it will work. I need to check. I'm not sure it's a 4. The labeling seems to be wrong on that. Uh, so, show IP interface brief. So it's .2, not .4. Okay, so we have the basic connectivity check, and I don't have to verify from other ones. It's definitely going to be working. So let's jump straight. So the first thing to do is to enable the tunnel interface. Which is we can use tunnel interface 1, tunnel interface 2, but I'm just basically going to be doing that. I enabled no shots, then the IP address that we have. I'm going to be following the interface IP address that we have here using this GRE IP address, which is 172.16.0.1. 255.255.255.0. No shots. I'm not sure if I've done that. The next thing I'm going to be doing is to issue the tunnel mode, which is GRE. What we want to establish is a multi-point tunnel. Uh, the difference between a multi-point and a static and a routed VPN is that in routed VPN we can do site to site. At the same time, which supports DMVP, which supports multicast, both unicast and multicast. But in this, we are going to be doing a multi-point DMVPN. The next thing is to enable the tunnel source. The tunnel source is the interface source where you are going to be initiating um, the DMVPN, which is E0/0. Then we move ahead to enable the NHRP. Um, the NHRP, first thing, I'll do the NHRP network ID, and I'll do the name, map it to multi-point dynamic. Now, the reason why we are doing dynamic, why is it? Okay, yeah, dynamic. It's because in DMVPN version 2, in DMVPN 2, we have each of the spoke communicating with the hub. They are statically mapping to the hub. So it is not the hub that is statically mapping to the spoke. So each of the spoke is statically mapping to the hub. On the hub, I won't be initiating multicast dynamic. I will be specifying the hub. On the spoke, I won't be initiating this command. Instead, I'll be doing a static mapping to each and every one of the hub. So basically, that is the configuration. If you uh, look at the basic configuration we have, this is what we expected. That is, when I say one touch, I mean once you have your hub configuration done, you don't have to do anything. Every other configuration can be done on the hub, and they will form static connections uh, to the hub router. So we will be moving to the hub now to initiate to continue the configuration. Okay, so let's move to spoke 1, where we'll have the let's move to spoke one. We have completed for for hub router. In the spoke router, in spoke one router, the configuration will be slightly different. The same, we bring up the interface tunnel, which is interface tunnel one. We assign their IP address. It's currently shut down. Just going to bring it up. We assign our IP address range 172.16.0.2 .2. Then we 255, not short. Then we enable we assign the tunnel to tunnel source. Our tunnel source is E0/1, as you can see here. As you can see here, E0/1. Uh, what is wrong? Tunnel source E0/1. Good. We assign the tunnel source. Then we also assign the tunnel. Well, the tunnel mode is GRE multi-point. GRE tunnel mode, GRE multi-point. Then the IP NHRP network ID is the next thing, which is 10. That is what we assign in the hub router. Then we move to the NHRP. What is our server IP address? Remember, this is the most confusing part of it. You need to use a private IP address which you assign for your for your hub router, which is 172.16.0.1. That is our server. Then we map it, NHRP map, NHRP map, the private IP address, then to the public IP address, which is 15.0.0.1. Then we define the NHRP multicast, map multicast to the private IP address 0.1. I believe this is all we need to be configured on the let me verify it again. We've configured the IP address, we've configured the tunnel source, we've configured the network ID, we have also configured the network server, yes. We have also configured the map, yes, and we have also configured the multicast. Have we done? Yeah, we've configured the multicast. So basically, that is all we need to do on this particular on this router. Similar configuration will be done on all other spoke routers. So I'm just going to copy the configuration, edit it, and paste it on my on other spoke router. So this is two. Why this is going to be? Oh, this is supposed to be one. I'm just going to adjust that IP address 172.16.0.1. No, it's two. This is one. This is two. This is three. Okay, so it's right. Okay, so this is going to be dot three, and same except this. Yeah, same. Let's check the interface to be sure this is going to be different. E0/2, and it's going to be multi-points. So good, fine. Let's go to spoke 2 and paste the configuration here. Here's the configuration. We adjust the same thing for spoke 3. So this is going to be 4, and the interface is 0/3, and we're just going to paste it like that on spoke 3. So we have spoke 3 to also have the same configuration. Now, what we have done is we have simply brought up our DMVPN. The only reason why it is not up is because let me just verify right now. Show DMVPN. As you can see, it has formed a static connection to this hub router. If I check on the hub router, show DMVPN, show DMVPN. As you can see the three sites 25, 35, 45. But right now, what we have only done is establishing a DMVPN connection between the four sites. We need to run a routing protocol and routing protocol. The underlying routing protocol is just for static routes. Each of these must exchange routes between each other, including the remote uh, the traffic behind those routers. So basically, what I'm going to be doing is to be um, configuring in the named mode EIGRP, as I've said at the beginning of this video. So in the named mode EIGRP is similar to router EIGRP. I'm just going to name it lab test. Okay, let's make it proper. 1, 2, 3, 4. So let's do EIGRP. I think that is the name of EIGRP. So the next is to specify, how we configure the name of the EIGRP is on like IPv4, the autonomous system number. Let's choose here, so 100. And we advertise on the hub router. What we need to advertise is the network behind the router. Don't advertise the one IP address. If you do that, you're just simply it won't work because you have the internet in between. So I'm just going to be advertising 10.1.1.0, 0.0.0.255, wildcard mask. Don't ask me why I need to do that. Then I'm going to be advertising the tunnel IP address. If you don't, the tunnel will not come up. So 0.0.0.255. So now EIGRP, oh, I'm not in classic mode EIGRP. I don't have to do no auto summary. So basically, this is what we need to do on each and every one of the router. As I've done in the initial video, I'm just going to copy the configuration, the EIGRP configuration, and paste it on the remaining router. I'm just going to limit it to that. And I'm going to paste it on spoke 1. I'm going to paste it on spoke 1. I'm going to advertise the network. Spoke 1 has 10.2.2.0, 0.0.255. And what is the private IP address? 172.16.0.0, 0.0.0.255. I believe doing this is sufficient to bring the tunnel up. As you can see, the tunnel is up. And it's fine. This is our desired result. I'm going to do the same thing on the other spoke, and we're going to verify our EIGRP configuration. On spoke 3, I have that, and my network is going to be 172.16.0.0.0.0.255. And I'm also going to be advertising on the top EIGRP 4.4.0 fast That's so I think that is sufficient. The same similar thing will go on my last route, 16.0.0.0.0.255. Or do I did okay? That's a glitch. Okay, I'm just going to. So what is behind 10.3.3? 10.3.3.0.0.0.0.255. So I think fulfilled, uh, I've completed the DMVPN configuration. As you can see, we have them dynamically linked. This is the interface is hub, and these are the remote tunnel. And this is each and every one of the routers. I mean, each and every one of the 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 sites that I land. And if you check for comprehensive show IP and HRP details, you can see each and every one of them has been landed. Uh, I'm not going to go through DMVPN version 3, DMVPN 3, because I can actually learn each and every one of them by disabling. Uh, because if I check show IP routes, each of them will have been installed in the routing table. The next stop will be this hub router. And if I'm going to stop that, I think the reason why they are not here is because there needs to be a static route that sends all the routes here and each and every one of the interface. But trust me, it is working as I planned. And they are dynamically land. And if you check here, it will have been statically land. So you can see it statically land here, and it will never expire. And the next, the NBMA is IP address is 15.0.0.1. So basically, this is what we have. In my next video, I will be explaining how to, because right now what you have is you have a DMVPN that is not protected with no protection on it. We can have an IPsec. We can have IPsec on it, which will protect the tunnel uh, with CIDAES, with SHA for decrypting, or I mean for hashing the clear text IP address. And for encrypting the tunnel, we can use AES 192 and the rest. But I'm going to be doing that without breaking anything in the lab. I'm going to be doing that in my next video. Then I think I can fix some of the bugs that I'm seeing here. I can see the EIGRP tunnel is breaking, but that is, I think I have my neighbors hub show IPIGRP neighbor. EIGRP neighbor. Okay, I have my neighbor. But my desired results will actually enable DMVPN 3 so that I can have each of the neighbor advertised here, not them passing through hub and going to each and every each respective of the hub of the spokes. Doing that, all I need to do is just to disable no next stop self, and I also need to disable no split horizon. So if I do that, I can have each and every one of the neighbor advertised on each and every one of the routers without uh, uh, making all my traffic pass through the hub. That's basically the configuration I'm going to be doing. In my next video, I will explain tunnel protection using NDM it's similar to configuring a route-based VPN. And that will be all for now. I'll see you in my next video. Thank you.